My name is Ciprian-Florin, student at Middlesex University, London, and with this video, I will demonstrate the usage of Robot Studio to simulate and test paths created by using the principles of manipulator programming, in this case, using Rapid as the programming language, which is similar to the other companies where they use a modified version of Pascal, such as KUKA Robotics and Comau. As can be seen, a SolidWorks model of Big Pen has been imported and attached as the tool, and it will be used to simulate drawing the initials of my name by using Move L and Move J, with coordinates created with manual jogging. I've also imported the CAD model of a table to represent where the paper will be in order to draw on it. As can be seen here on the left, I have the pen holder and then the table itself, all created in SolidWorks. After I'll demonstrate the drawing of my initials, I'll show how I'm drawing a vector of a sword that has been generated by using Robot Studio's AutoPath feature. And the model itself is a sword that has been created in SolidWorks specifically for this project. And thanks to the AutoPath feature, all the different waypoints have been generated automatically. If I now switch to the Rapid code, once it is loading, let me go here on the left on my module. You can see how as constants, I have all the different waypoints. As variables, I have all the different inputs from the user, all the different values from the user that need to be stored. As in the main routine, I am asking the user to input the different tasks that he wants to do with the speed and the amount of times to loop that. So in the main routine, I am checking if I should run the program, and then depending on the input from the user, which is presented here with TP read, and then shown back with TP write on the flex pendant, a different subroutine consisting of the paths that need to happen will happen. So if I scroll down, I have the two subroutines representing either the amount of loops of how many times the path should repeat, or the speed multiplier, which will change the global speed of the entire system between 20, 40, 60, 80, and 100%. And then I also have the different subroutines for all the different paths. So the home path, table path, selector, so far and so on, all with the necessary comments in order to specify and explain what every line of code does. If I go back to the controller now and I turn on the controller, once the controller loads, which I have it here, I can then go back to Rapid and run the code. Now that the code is running, I can now go back to the flex pendant and take the flex pendant and move it to the screen where the user is being asked what procedure would they like to complete. In my case, I can go to the home point. I can perform the path of the table perimeter. I can draw my initials. I can draw the sword vector, or I can exit. So if I press the exit, I can go back to the main code in order to modify it, for example, or run a different code. Now let's switch back to the view of the entire system right here in the home. So if I go here on my flex pendant, and let's say I want to do the table perimeter, I can choose the table perimeter. Then it will ask me the selected procedure is the second one. How many times would you like to complete the procedure? So how many times do I want to loop it? Let's say that I want to loop the perimeter of the table 2 times. So I choose that, and then please choose the system global speed. I'll choose 100% this time. Now, once all of this has been done, the robot arm will start moving, as can be seen here. While the robot is running, we can also see the exact procedure that it does in the subroutine representing the path. In this case, I'm using move L for all the different movements with speed V1000 and accuracy for curves of Z15. Once this completes, you will do it again, as I have set to loop twice. So as you saw, it stopped there, it waited 1 second, and now it is looping again, and then it will return to the home point as has been set. If we look here, we can see the home path, for example. So it is now doing this, it's now completing, and it will now return to the home point. Now that the procedure has completed, the system returns back to the menu, asking the user what would they like to complete again, what type of subroutine would they like to perform. So let's say I want to do the initials. I want to do them once at 100% speed, just for the point of demonstrating the different initials. Now for the movement from home to the initials, I've lowered the speed tremendously so that in case there is an object, the system user has enough time to move the obstacle out of the way so that the paper is clear for the robot arm to draw the initials. Once the robot arm reaches the first point, which is right here, it will be way faster. So let's wait for that to happen. As we can see here, it will go to the first point, which is C first jump. All the different waypoints that are higher than the table or the paper it themselves are called with an underscore jump, so that after it finishes the actual letter, finishes drawing the letter, it will jump and then go to the other letter without continuing to draw on the piece of paper itself. The simulator needs to represent the real world scenario. So now that we've reached that, it will do the C. So now you can see how it does the C letter. After finishing the C letter, you will go and draw a line between the first name and the middle name initials. And you will now go to the letter P. Now, of course, in the real world, depending on the task, the speed can be increased in order to optimize the code so that it runs way faster. Now, I'm just going to correct myself. I said the letter P, it is the letter F. There's just a jump between the 2 points so that the robot arm does not draw that line there. And once it reaches this point here, it finishes the letter F as well, and you'll go on to draw the letter I, followed by a final dot. While the robot arm is completing the last letter, it is important to talk about the speed refresh function, which is being used in order to take an input from the user, and depending on that input, give to the system either 20%, 40%, 60%, 80%, or 100% of the speed that has been set in the system. So if in the path itself, in the move-L function, for example, we've set F100, and then the user in the input chooses 20%, it will then become V20 instead of V100. Now, speed refresh is a very important function because again, in a factory environment, in the real world scenario, we can easily swap out the input from the user with an actual sensor, an ultrasonic sensor or an infrared sensor, or even a camera with computer vision, which measures the distance between the robot arm itself, the system, and either humans or users and objects around the system, which will then reduce the speed of the system proportionally to the distance between the user and the system. So as an example, if the user is at 5 meters away from the system, the speed can be reduced to 80%. If at 3 meters, the speed can be reduced to 60%. If at 2 meters, the speed can be reduced to 40%, and at 1 meter, reduced to 20%. Anything lower than a meter, the entire system stops and exits the program. This can be extremely easily implemented, and the code does not require much modifications. We can see how the mover home has a V of 500, and it is moving way faster to go back to its home, which is right there, as we can see from the waypoint. If I just shift this a bit, and let me just move the flex pen out, span it a bit and rotate it. Now, since we've completed the initials, the system asks me again to complete something else. So we can go with sword vector. Again, it's just a sword with a path created by using the AutoPath feature available in Robot Studio. So if I choose that and I go only once and 100% speed, you'll now move towards it and complete the vector for that. Now we are approaching the endpoint. So we finished drawing the vector of the sword, and we will now return back to home. So now that we've returned back to home, the menu is presented again to the user. So in this case, I have finished all the tasks that I wanted to complete, and I can just press exit, and I will leave the code itself. For this last part of this demonstration, I will now show how I can change the origin of my work object, and the program will still execute accordingly. So if I go here to my work object, so you can see I've selected it, I can offset the position. So let's say I'm offsetting it by 25 on the Z, 100 on the Y, and 50 on the X. And let's say I'm doing a minus 3 degrees on the Z and 5 degrees on the X. So now I can apply. You can see how the entire work object has shifted. Can now go to the rapid code, synchronize everything, and then just run it. And without modifying anything else, can go back to my flex pendant, which is here. Let's say I want to do the table perimeter, and I want to do it 2 times at 100% speed. So you can see how the part is still completed, and you can see how it got completed twice. And now let's also try with the initials. So let's go to initials once, 100% speed. So let's see how that completes. So now we have the letter C, then we have the line, the letter F, the letter Y, and the dot at the end. All of that without having to edit anything in the program itself. And now I can just exit, and I've executed the code. With all this said, this concludes the video demonstration, and I would like to thank you for the time dedicated.